Hi my friends, we start another tutorial based on the previous one, a new variant. In fact, this is a flanged screw where the flange is here with dimensions 36, just like this, because they must be identical, and the depth of 0.5. This is lathe part of our piece. Good. And then we'll use a table to create a family with or without flange, because you see here the dimension is A, and this dimension is missed on some parts, some lines. Our part now is the bottom line. This is our part. 24 is the diameter, this. And we have to create all these parts as a family. We'll see everything in the following tutorial. You remember this part made in the previous tutorial, and now we'll start with creating that flange. To make this, we create a sketch in a diagonal plane, F7 to see inside, project geometry, axis Y, and creating a rectangle of 0.5 depth. And now we look to the table to see what is this dimension which is needed. The table of parameters is here, and the dimension is D0 of 36 millimeters. Let's create this dimension here with D0 as value. Finish sketch, revolve, select axis, cut the part, OK, and now the flange appears under the head. This is the feature flange. We can change here the name with that name, flange. Why not? Good. And more than this, we can suppress this feature using this option, suppress feature. It disappears, and anytime we can unsuppress feature to have it back. This is very important and is new for this new tutorial. Every tutorial comes with new abilities. So the next step is to edit the parameter table to put here all the names from the table, from our table. DIA is metric 24, L is 120. You remember from yesterday. B is 56, and so on. Let's do it. This is S hex. This is K. Take care of capital letters here you see S hex is half of dimension here. This is L, capital L. This is DIA, D capital, the rest EIA. Okay, the rest not capital. This is chamfer, cham, enter. You see here S hex, DIA, L, K, cham. We have B, R, and A. Good. This is 54, but this is obtained from B minus chamfer. The chamfer of 2 millimeters. This is why we need to create a user parameter with the name B and with the value 56 in order to put here an expression B minus cham to have the same value here, but coming from an expression. Here is 08R, not capital, and A, not capital. Now these are all the symbols in our table. They are reflected on this line and on our parameter table. Okay, done. Nothing is changed to the model, of course. Good. After changing the names of symbols in the parameter tab, we have to create the family. We make this activating the Manage tab and the tool Create I part. Now we see here a line with all the data for this part, and because we want to create a family, we have possibility to insert rows here. You see 01 is now 02, 01 is 02, because they are a series and not the same, even if all the data are identical with the previous line. We change this because we have our table. This is the table, and because we want to create now say this line, we will use the data from here. 2.5 is the pitch, but this is not important. L is 100, B is 54, and so on. Let's change this data with the real one. 32 here, 14 here, 100 here, 22 diameter. The chamfer is the same, 2. The radius is 0.7. A is also 0.5, and B is 54. Good. Okay, you see here the browser, and nothing between this. Be very careful what happens looking here. OK, and a new article, a new entity is here with screw 01 on the first line and checked, and the other 02 on the next line not checked. If I double click here, look to the model, double click, and the model is changed. Why? Because now the diameter here is 22, for instance. I use measure from inspect, measure, which can be invoked with the M for this, and you see 22. Oh, very interesting. Escape from measuring. More than this, if I double click here, I see the table, and this line is now in focus. Yes, but this is not all. Look here, I use right click for edit via spreadsheet, and this will open the Excel program with all the data from here. Changes via spreadsheet will take effect after the Excel process is closed. You have to have installed Excel here. OK, and you see, let me place in a better position. You can see here what rich is the table 0102. I can copy this line, copy here, but I have to be careful with the name 3, not 2. 3, not 2. But this is simple. You know how can do this. So, and here I'll put the data from the next line. Next line is with 30 here. $13 here, 90, 20, also 2 millimeters for chamfer, 06, A is not present. This is interesting and we'll discuss about. And here is 52. All I want to do is to show you that when I save this Excel file, I'll save it and I close Excel at all. Now I have another member here. Yes, double click on it, will bring here the new measure M, mama, M from mama, and we have 20 now. Yes, escape, this is 22, this is 24. If you prepare an Excel table before, as this one, you can copy your table in the Inventor's table taken from here. Double click here. This is the table. All the lines are here. I'll make this for you and I'll show you in a moment. Okay, now I prepared my Excel table, and you can see here all the data in other order. Yes, here is S hex and so on, just like in this table. S hex, KL, dia, cham, and so on, in that order. There is a problem with this data where I put minus sign because I don't want A to appear. I don't want the flange to appear. I'll change this with the value, say 1. Copy this, but we know what I intend to have here. 1 and 1, 1. This is the table. I'll copy these values in this order from 8 to 36 immediately. I do this using the editing via spreadsheet. Edit via spreadsheet with the mention wait for Excel to end. Here we have all the data. I know that there are from 13 to 2 there are 11 lines here, important lines, data lines. So I develop the same number numbered from 1 to 11 here and here. This must be different, each one. This one, these are not important, but this one must be different numbers. And now I'll change all the data here with my values from 8 to 65. Copy here, paste as they are. Okay, with colors nothing is important here in this matter, and I save it. You don't see, I make again, I save it and I exit. This is different. The values here does not match the values in the active row. Okay, I'll see what happens. Accept. Maybe they are not numbers but text. Edit via spreadsheet, and I'll change all of them as format cells number. Okay, or point. Save again, and now the first one is here. There is a problem with the thread. The thread is not defined here correctly. Look to this. Errors because the thread is not inappropriate thread size. to solve this problem, we have to work on we open the table in Inventor. Let's modify here to have all the table visible, and we choose threads, and we move here some characteristics or features of the thread to the right, and they are here. Thread pipe thread designation, this is the name only, and the diameter, which is taken from here. I cannot copy them. I tried. You are my witness. Okay. This is not okay, of course, but I accept it. Everything must be made in an order. You will find the way if you work on, and using Excel is better. Why is better? Because we have a lot of possibilities here. We choose, we copy this to here, okay. I changed this table by adding all the necessary data here, since we changed some columns without values. Now the values are okay. These values were copied in the Inventor table. The Inventor table is this. I copied them here, and now I save, I close, and I don't have a message. The threads are now very okay. This is M metric 5, this is metric 2, metric 6, so on. It grows, and this is our F6 to see all. Our initial screw. If I change here, I see smaller screws, and where you see a large flange, it means that the table has the value 1. Yes, for A. Now, when this value appears, this means that I don't want here to have flange. I want to suppress the feature flange, which is here. You see it? I want this to be suppressed for some of our 11 parts in the family. How do we this? We do this using another tab from here. You use threads. When we carried from the part to the table some elements. Now suppression. Suppression of what? Suppression of flange. this is the flange. I copy here and the flange appears. It appears with all the values compute. This means unsuppressed, because I want to suppress all the values of 1. The lines where appear the value 1 for A. I put here the letter S from suppress is enough. S. I can make this with Excel, is simpler. Open via spreadsheet, and now we observe the last column here, and we change copying, copy, paste, paste. The things are simpler than you imagine. Yes, I cannot present them very I have no time to make all the presentation, but now you are advised. Okay, I close this, and you will see how this flange disappears at the first. You don't see any flange here. Second, and so on, based on 12, 16, 22 and 24 must have flange. You see here is suppressed automatically. Here the flange appears. What dimension is now? M. This is 12, and 12 is with flange. Okay, my friends, this is all I wanted to present you. Escape now. You have now a family of parts. You save them. Of course you have to change here, yes, to use Excel, I suppose, to change these names with the proper names. Here everything is okay, but here you have to change. I have no time to make this. Do yourself. Have a nice time, and please subscribe to my channel to have more and more tutorials. Bye bye.